Okay, good day to you and welcome back. So, as discussed in our previous videos, today we'll be talking about the storage system. So, there are basically two types of our storage system. We have the hard disk drive and the solid state drive. And then we also have two types of interfaces for them. We have the NVMe and the starter. So storage device provide long-time data retention capability. So from the word storage, it means that they are used in storing our files, our videos, our data, our operating system on a computer system so that we can be able to get access to them at any time in point that we need them. So we have two type of storage device, which is the hard disk drive and then the what SSD, which is the solid state drive. Don't forget we are talking about the system storage device because there are other external storage devices that are in existence. But this one in particularly is we are referring to the system storage device, which is your hard disk on your laptop, on your desktop, right? So both the HDDs and the SSD serve as storage device for computers, but they differ significantly in technology, speed, durability, and then cost, right? So the hard disk drive technology is such that it relies on mechanical parts. As you can see over here, there are various mechanical parts, specifically the spinning magnetic disks, which is this particular one, right? The spinning magnetic disks. That is, we are talking of this, which is the spinning magnetic disks, which is also known as the what? The platters. And then a moving read-write head to access the data. So this is what they are talking about. The moving read-write head that what? Access the data. And then we also have the actuator and then the actuator axis and the actuator itself, right? So the speed of the hard disk is due to the physical movements involved. HD have slower read or write speed compared to what? The SSD, usually ranging from 80 megabytes per second to 160 megabytes per second. So that is how fast your hard disk can go. So it can go between the range of 80 megabytes per second to 160 megabytes per second, depending on the what? The type of hard disk you have, right? And then the capacity. Hard disks are available in large capacity, ranging from 500 gigabytes to 20 terabytes or more. So depending on most of recently you can see on the system is 1 terabyte, but its capacity can reach up to like 20 terabytes at an affordable price and making them ideal for what? Bulk storage. So that's why you see in most what's it called, in most server rooms, in most organizations, they use the HDD because it is a bit more affordable than the SSD. Then the durability, hard disks are prone to what? Physical damage due to their moving parts. So because all these parts are moving between each other, when this is spinning, this one will be automatically move onto it to read and write, right? And this one controls the movement of the what? The actuator arm, which is here is the actuator axis, and the actuator arms move the what? The read and write head that read the information from the what? The platters. Then its use case is such that it is archivable storage and can be used for backup and budget-friendly system that require large amount of storage but do not need high speed. And the cost is more cost effective per gigabyte compared to what? The SSD, making them a budget-friendly choice for what? Large-scale storage. Then we have the solid-state drive. So the solid state drive differs in the SSD drive due to its technology. Even by merely looking at it, you can see that the technology differs. This one has a mechanical part, while this one does not have a mechanical part. So the SSD is basically made up of a flash memory, just like the normal flash card that USB card that we know, right? So that is how the SSD was also designed to perform. right? The SSD used a flash memory and a NAND chips with no moving part at all. So you can see there's no any moving part unlike the HDD, allowing them to access and store data electronically. Then the speed are significantly faster than the HDD, with read and write speed ranging from 200 megabytes to 550 megabytes for starter SSD. You know, we said there are two different interfaces. So we have the starter SSD, and then for the NVMe SSD, is the speed ranging from 3000 megabytes per second, right? Then the durability. Since SSD have no mechanical components, they are more resistant to shock, drop, and wear, making them more reliable in long run. So that is why whenever you are handling your HDD, you have to be very careful because it has a moving mechanical part inside them. So if you drop it anyhow, if it falls from any particular location and then the mechanical part is disarranged or dislocated, then it will not function properly as it's supposed to function, or it might even cease to exist, right? But unlike the HDD, the SSD does not have any moving mechanical parts, and such, if it falls, it has minimum damage compared to when an HDD falls down. Then the use case is ideal for what? Operating system, gaming, high-performing computing, and application require fast data access. So because the speed as you can see from the speed of it, which ranges from 200 megabytes to 550 megabytes or even 3000 megabytes. So it is mostly used when you require more computing power, when you are playing games. So that's why you see them in the latest gaming system. Because as I've discussed when I was discussing about the memory, I told you that whenever you are using an SSD, it serves as a virtual memory as an addition to your original RAM on your system. So the SSD complements any RAM that is existing on any system. So that's why when you overload the system, you will notice that your SSD space is being increased. So if you are using SSD on your system, you can bear witness to that and monitor how your SSD operates. Whenever you overload your system, you see that your SSD space increases, and when the load reduces, the SSD space comes back to its normal size. And even when you have already filled it up with a lot of data, and then you overload the system again, you see that the system will now start slowing down. So unless you stop some software, you stop some processes, then before you can see that your system will not stop running back as required. Then it costs. SSD are more expensive per gigabyte compared to the HDD, but the price has been steadily decreasing over time. As more people are adopting to the use of it, the price is also getting lower. As more demand is, as they are producing more of it, then the price is also getting lesser. So we said there are two interfaces. We have the starter interface versus the NVMe interface, right? So when choosing an SSD, one of the biggest factors is the interface it uses, with NVMe and the starter being the two type of option that we have. So for the NVMe, which is also known as a non-volatile memory express, its technology is such that it uses a peripheral component interconnect express, right? Interface, which offer much faster data speed than starter, right? Then the speed of the NVMe SSD can achieve read-write up to 3000 megabytes to 7000 megabytes per second, and even higher with newer models, making them ideal for what? High-performing tasks. Then latency. The non-volatile memory express has lower latency than the starter because it handles multiple data queues simultaneously, improving what? Efficiency. Then use cases is that it is best used for what? Gaming system, video editing, professional workload like 3D rendering, AI stock machine learning, database server, and high-speed computing. So the NVMe is the fastest of the what? The SSD. And then the cost. NVMe SSD tends to be more expensive than the starter SSD, but offers much better performance. Then we have the serial data. The serial data is an older storage interface primarily designed for what? The HDD. So if you have ever seen an HDD, you will see how the interface of the starter is. So, but it is also used for what? Early SSD. So early SSD also have the same kind of interface. If you observe this one now, it's more like a what? And a starter interface, right? No, this one is not a starter interface, it is a NVMe interface, yes. So it is an NVMe interface. I wish I have the image to demonstrate that, okay? But you can research it so that you can see the difference between the NVMe interface and then the starter interface. So the speed for the starter interface is limited to speed of around 500 to 600 megabytes due to the interface bandwidth constraint, right? And then the compatibility works with almost all computers, making it a universal option for SSD upgrade. So now, advantage of the starter NVMe is that it is also a SSD, but it's just that the NVMe is more faster. But if you are trying to upgrade your old system that uses an HSD, so it's more easier for you to upgrade it using a starter SSD, because the port will be the same as that of the HDD and you can easily plug it in, right? So that is why it works with almost all computers and it is a universal for what? SSD upgrade. Then the use cases that is good for general computing, boot drive, and budget SSD upgrade when extreme speed isn't necessary. Then the cost is more what? Affordable than the what? The NVMe SSD, making them a great balance between price and performance. So that's about the storage system. And then you have an assignment. Let me add one assignment to this. So let me just add one more assignment to it before I announce it. Okay, so now I want you to browse and research the physical interface of the two storage system interface. So, and submit the image with labeling. So the first assignment you do is that you are going to explain what RAID is, its configuration, and then data redundancy. So I want you to explain what is RAID, and then what is data redundancy. Then you list the level of the RAID levels and explain each one. Then you also list all type of CPU in existence of the 21st century and explain how they work briefly. Then finally, browse and research the physical interface of a two storage system interfaces, as we have discussed, and submit their images with what? Labeling. So that is all for this part until we meet in the next discussion. Thank you.